Namaste. Welcome to Blishon Concept Teaching, Class 10 NCERT Syllabus. Today we are going to solve the problems on polynomials, exercise 9.2, second main questions. But before solving that, we must know this information. That is, if alpha and betas are the zeros of quadratic polynomial p of x, then the polynomial p of x can be written as p of x is equal to k into x square minus sum of zeros into x plus product of zeros. That is, p of x is equal to k into x minus alpha plus beta into x plus alpha beta, where k is a non-zero real number. This one is very important to solve our exercise 9.2 second main questions. And the meaning of this is, when the zeros of the polynomial is given, then the polynomial can be written in this form. This is the meaning of this. Okay? If you want the complete detail of this, please let me know in the comment section so that I can do a separate video to explain this. Okay? But to solve exercise 9.2 second main, this one it is enough. Just try to understand, when the zeros of the polynomials are given, then the polynomial can be written in this form. That is, p of x is equal to k into x minus alpha plus beta into x plus alpha beta, where k is a non-zero real number. This much information is enough to solve exercise 9.2 second main. But if you want a complete meaning of this, please let me know in the comment section. Okay? Let me rub this and we will move to the exercise 9.2 second main. Exercise 9.2 second main. First let us read this. Find a quadratic polynomial. Here, what we have to find? We have to find a quadratic polynomial, each with the given numbers as the sum and product of its zeros respectively. What is the meaning of this? What we have to find? We have to find a quadratic polynomial. That is, p of x we have to find. Isn't it? What is given? Each with the given numbers as the sum and product of its zeros respectively. What they have given? Sum and product of zeros. Say 1 by 4. It is what? It is the sum of its zeros. Means what? Alpha and beta are zeros of polynomial. Right? Zeros of polynomial. And they have given 1 by 4 is the sum and minus 1 it is the product of zeros respectively. Means what is given in the problem? Alpha plus beta. Sum is 1 by 4. Okay? Then product of zeros, that is alpha into beta, is what? Minus 1. What we have to find? We have to find p of x. How to find p of x when the sum and the product of its zeros are given? We already know the form. That is, p of x is equal to k into x square minus alpha plus beta into x plus alpha beta. Right? Let us do that. What is given? Alpha plus beta, that is 1 by 4, and alpha beta is equal to minus 1. This is the sum of the zeros and this is the product of its zeros. What we have to find? We have to find p of x, the polynomial. When the alpha and beta is given, the zeros of the polynomial can be written in the form of p of x is equal to k into x square minus alpha plus beta into x plus alpha beta, right? Where k is a non-zero real number, right? Then p of x is equal to k into x square minus, say, they have given the value of alpha plus beta, that is sum of the zeros, is what? 1 by 4. Therefore, in the place of alpha plus beta, I will write 1 by 4 into x, okay, plus alpha into beta, that is product of its zeros is minus 1, okay, alpha into beta is minus 1. P of x is equal to k into x square minus 1 by 4 into x is 1 by 4 x. Plus into minus is minus 1. P of x is equal to k into. Now look at this, 4 is in the denominator, right? Nothing is here means we will write 1. And here we will write 1. 1, 4, 1. The denominators are different. So we will take the LCM of 1, 4 and 1. What is the LCM? 4 is the LCM, right? Then to equalize the denominator, we will multiply this by 4. 1 into 4 is 4. X square into 4 is 4x square. Minus 4 into 1 is 4. Therefore, we will multiply it by 1. That is 1 into 1 is 1 into x. That is 1x. Simply you can write it as x. Here 1 into 4. Right? 1 into 4 is 4. 1 into 4 is 4. Then see here. Look at this. Here it is minus. So let me write minus. Okay. Now let me rub this one. Now look at this. 4 is in the denominator. I want to cancel this. So what can I do? I can take the value of k as 4. Okay. By taking k is equal to 4. If I take k is equal to 4, what happens? See, p of x is equal to, in the place of k I will take 4, then it will become 4x square minus x minus 4 divided by 4. This 4 and this 4 it cancels, right? Then what is left? P of x is equal to 4x square minus x minus 4. It is left. This is our P of x. This is our answer. That is, the polynomial in x is 4x square minus x minus 4. This is how we will find the polynomial when the zeros of the polynomial is given. But keep it in mind, here they have given the sum and product of the zeros of the polynomial. Directly they have given alpha plus beta and alpha beta. Okay. Now let us do the second problem. Let us solve the second problem. We know that sum and product of the zeros of the polynomial is given and we have to find out the quadratic polynomial. That is, what we have to find? We have to find P of x. What is given? That is alpha plus beta. That is root 2 and alpha beta, that is 1 by 3. This is given in the problem. When the zeros of the polynomial is given, Then to write the polynomial p of x, then what we will write? We will write p of x is equal to k into x square minus alpha plus beta into x plus alpha into beta. Okay. Now p of x is equal to k into x square minus alpha plus beta. The value of alpha plus beta is root 2. Okay. So let us substitute in the place of alpha plus beta. We will write root 2 into x plus alpha into beta. That is, the value of alpha into beta is 1 by 3. 1 by 3. P of x is equal to k into x square minus root 2 into x is root 2x plus 1 by 3. Okay. Now look at this. Nothing is in the denominator means we will write 1. 1, 1, 3. The denominators are different. To equalize the denominator, we will take the LCM of 1, 1 and 3. Isn't it? That is, 3 is the LCM. Now to equalize the denominator, we will multiply this 1 by 3. P of x is equal to 3. It is the LCM. Right? Therefore, divided by 3. To equalize this 1 to 3, what we will do? We will multiply it by 3. 1 into 3 is 3. 3 into x square. Minus, for this minus let me write minus. 1 into 3. Here also we will multiply it by 3. 1 into 3 is 3. 3 into root 2 is 3 root 2 x. Okay. Plus. Already we have 3 is in the denominator. So we will multiply it by 1. Okay. Now look at this. Now 3 is in the denominator. I want to cancel this. What we can do? We can put k is equal to 3. Okay. So that we can cancel this 3. Therefore, by taking k is equal to 3. P of x is equal to k is 3. 3x square minus 3 into root 2x plus 1 divided by 3. Now look at this. This 3 and this 3 it will cancel. What is left? 3x square minus 3 root 2x plus 1. It is left. That is our P of x. Okay. Let me rub this. P of x is equal to 3x square minus 3 root 2x plus 1. This is our answer. Okay. Plus 1 you have to write here. There is no place, so I have written like this. Okay. This is our quadratic polynomial. By using the sum and product of zeros of the polynomial, we have found the polynomial. Okay. Now let us solve the third one. Now let us solve the third problem. We know that 0 and root 5, they are the sum and product of zeros of the polynomial. Isn't it? See here. 0 it is, what is given? Alpha plus beta. That is the sum of zeros of the polynomial is 0. Then the product of zeros of the polynomial is root 5. This is given in the problem. What we have to find? we have to find P of x, right? Then how to find that? We know that when the zeros of the polynomial is given, the polynomial can be written in the form of P of x is equal to k into x square minus alpha plus beta into x plus alpha beta. Isn't it? Where k is a non-zero real number. Now look at this. P of x is equal to k into x square. For this minus, let me write minus. Alpha plus beta, that is given 0. Alpha plus beta is 0. 0 into x. Okay? Plus alpha into beta, that is root 5. Root 5. P of x is equal to k into x square minus 0 into anything is 0. 0 plus root 5. Okay? P of x is equal to k into x square minus 0. No need to write this one. Plus root 5. Now, in the previous problem, what we were doing? See, there is a slight difference between the previous problem and this problem. In your previous problems, the zeros of the polynomial, they are given in fraction, so that we were getting the number in the denominator, right? But in this problem, there is no fraction. Okay? So, what we have to do? Now, let us take k as 1. Okay? By taking k is equal to 1. P of x is equal to, in the place of k, let me take 1. X square plus root 5. Okay? Therefore, the P of x will be x square plus root 5. Okay? Hope you have understood this one. Let me solve the fourth problem. Let us solve the fourth problem. We know that 1, 1. What are these? These are the sum and product of the zeros of the polynomial. That is, what is given? Alpha plus beta is equal to 1. Alpha into beta is equal to 1. It is given. What we have to find? We have to find P of x. When the zeros of the polynomial is given, the polynomial can be written in the form of P of x is equal to k into x square minus alpha plus beta into x plus alpha beta. Alpha into beta, where k is a non-zero real number. P of x is equal to k into x square minus the value of alpha plus beta is given, that is 1. So, in the place of alpha plus beta, let me write 1. 1 into x plus alpha into beta, that is 1. Okay? P of x is equal to k into x square minus 1 into x is x plus 1. Okay? Now, just remember your previous problems 1 and 2. They have given the zeros of the polynomial, that is the sum and product of the zeros of the polynomial in fraction. But the question is not given in the fraction yet, right? So, no need to worry. So, by taking k is equal to 1, by taking k is equal to 1, that is P of x is equal to, in the place of k, let us write 1. Therefore, we will get x square minus x plus 1. Okay. P of x is equal to 1 into this one is how much? X square minus x plus 1. We have got the polynomial. Hope you have understood. Let us solve the fifth one. Let us solve the fifth one. We know that they have given the sum and product of zeros of the polynomial. That is, what is given? Sum of the zeros of the polynomial. That is, alpha plus beta is minus 1 by 4. And the product of zeros of the polynomial, that is alpha into beta, is 1 by 4. It is given. What we have to find? We have to find P of x. Right? When the zeros of the polynomial is given, the polynomial can be written in the form of P of x is equal to k into x square minus alpha plus beta into x plus alpha into beta. Right? Now, P of x is equal to k into x square minus alpha plus beta, that is given, minus 1 by 4. So, in the place of alpha plus beta, let me write minus 1 by 4 into x plus alpha into beta, that is 1 by 4. 1 by 4. P of x is equal to k into x square minus into minus is plus 1 by 4 into x. Okay? Plus 1 by 4. Now look at this. 1, 4, 4. It is in the denominator, right? Whether the denominators are equal? No. To equalize the denominator, we will take the LCM of 1, 4, 4. That is 1, 4, 4. 4 ones are, that is LCM is 4, right? Therefore, we will equalize the denominator. P of x is equal to k into 1 into 4, right? Because we are equalizing the denominator. 1 into 4 is 4. 4 into x square. 4x square plus. Already we have 4 in the denominator. Therefore, we will multiply it by 1. 4 into 1 is 4. 1 into 1 is 1x. Simply we can write it as x plus 4. Already we have 4 in the denominator, so we will multiply it by 1. Now look at this. We have 4 in the denominator. So I want to cancel this. So by taking k is equal to 4. By taking k is equal to 4. P of x is equal to, let us write 4 in the place of k. 4. 4x square plus x plus 1 divided by 4. Look at this. This 4 and this 4, it will cancel. What is left? P of x is equal to 4x square plus x plus 1. Okay? This is our polynomial. Okay? Now look at this. In your fourth problem, in the question they did not give fraction. But here in this question they have given fraction. So in the place of k, we are taking the same value that is in the denominator. We are taking 4. Okay? Now let us solve the sixth one. Let me rub this. Now let us solve the sixth question. We know that here the sum and the product of zeros of the polynomial it is given and we have to find out the polynomial. That is given, that is alpha plus beta. The sum of the zeros of the polynomial is 4. It is given. And the product of zeros of polynomial is 1. This is given in the problem. What we have to find? P of x. Okay. When the zeros of the polynomial is given, the polynomial can be written in the form of P of x is equal to k into x square minus alpha plus beta into x plus alpha beta. Okay. Now look at this. P of x is equal to k, where k is the non-zero real number. X square minus the value of alpha plus beta is 4. So in the place of alpha plus beta, let me write 4. 4 into x. Okay. Plus alpha into beta, that is 1. P of x is equal to k into x square minus 4 into x is minus 4x plus 1. Now let us take k is equal to 1 by taking k is equal to 1. P of x is equal to, in the place of k, let us substitute 1. Okay. X square minus 4x plus 1. P of x is equal to 1 into this one. It is what? Same we will get. That is x square minus 4x plus 1. This is our required polynomial. This is what they have told us to find, and we have found this by using the zeros of the polynomials. Right? Hope you have understood. Stay connected. Keep supporting. Thank you.